what we did in the last class, और उसमें था that acids and bases, we talked about acids being proton donors and bases being proton acceptors. Okay, so this is what we did, and we talked about the importance of water. We talked about that water has two ions. One of them is H+1, the other one is OH-1, and we talked about the concentration being equal, so that is a neutral pH. We talked about that if you add an acid, it's a molecule that increases the H+1 concentration in the solution, so that makes things acidic. And there were bases, they would decrease the concentration of H+1 and increase the concentration of OH-1. So those were that would make the solution basic. So water is everywhere. Water is the main medium in which reactions happen. TK, every reaction is happening on planet Earth mainly because of water, because particles can sort of move around and they can bump into each other. So water is very important. So the type of water that you have, whether it's neutral, acidic, or basic, that also is very important. Reactions are very sensitive to pH. So we talked about acids, molecules that produce H+1 ions, and we did we wrote down all the names of all the acids which you've already studied in your O-levels. And then we talked about bases. I told you that bases are the things that accept H+1 ions, or vice versa, they produce OH ions. But technically, the definition for a base is that it produces, it accepts H+1 ions. So what a base would do is that in water, it would decrease the concentration of H+1 ions, and it's going to increase the concentration of OH ions in water. So which substances are basic? O-2 ions are basic, OH-1 ions are basic, CO3-2 ions are basic, NH3 molecules are basic. They all tend to accept H+1 ions. For example, these two, they end up forming water molecules. Carbonate ions, they accept H+1 to form water and carbon dioxide. NH3 also accepts H+1 ions. So these were all your bases. Metal oxides, hydroxides, carbonates, TK, etc. All these compounds were basic. And we did do the first reaction, which was a metal plus acid reaction. That was the reaction that we had done last time. Okay, we did a base plus acid reaction, a metal oxide, hydroxide reacting with an acid to produce salt plus water. So I'm going to cover all the other reactions as well. So let's just quickly recap this reaction first. So starting with the same reaction. Remember, metal oxides, hydroxides, for example, if I have aluminium hydroxide, that would be Al3 plus, OH is -1. So that is going to be Al, OH3. Plus if I have nitric acid, so that is HNO3. If I react it, a water molecule, a salt, and a water molecule is going to be produced. So a salt is simply, get rid of the H, and the OH ions are forming water. So whatever is left, that's your salt. So in that case, that would be aluminium nitrate. Al is 3 plus, NO3 is -1. So this is what the salt is going to be. I told you some rules about balancing, that when you start balancing, balance the easiest first, the ones that appear the least number of times. For example, aluminium, only in 2 places, that's already balanced. Don't balance H or O initially because they're everywhere. Balance N, there are 3 nitrogens over here. So over here, there's going to be 3 HNO3 molecules. TK, imagine them as imaginary brackets. TK, you don't put brackets. Just to clarify, I'm putting these brackets that there are 3 molecules of HNO3. So then balance the O is everywhere, so don't balance that. Balance H first. It's in 3 places. So there are 3 H's, that's 6 H's. So you'll multiply this by 3. The most difficult one, the oxygen, would automatically be balanced. There are 3 oxygens, 9 oxygens over here. So that's a total of 12 oxygens. And then 9 oxygens plus 3 oxygens. So that's a total of 12 oxygens. So that's our base plus acid reaction. This was a metal oxide plus metal hydroxide reaction. Then I'm going to move to the second reaction, which is quite similar. It's a metal plus acid reaction. And that produces salt plus H2 gas. That is what is going to be produced. This reaction is a redox reaction. It's not an acid-base reaction. It's mostly a redox reaction. We'll discuss redox later on. So this one is a redox reaction. And not all metals react. Some metals are very reactive. Are very reactive, while others are very unreactive. So if you remember O-levels reactivity series, group 1 metals were extremely reactive. So they would react explosively. Then you had metals that were at the bottom of the reactivity series and their reactions were very, very slow or non-existent. For example, copper, gold, platinum, etc. They hardly reacted. They would react if the acid is very concentrated at very high temperatures, but otherwise gold is not going to react. So the reaction and the speed of the reaction depends a lot on the reactivity of the metal. But here we are at the moment just discussing the equation. So pick any metal and you react it with an acid, let's say hydrochloric acid. So a salt would be produced and H2 gas would be produced. So the salt in this case would be get rid of the H and put Mg in its place. It's going to be Mg. Mg is 2 plus, group 2. Cl is 1 minus. So it's going to be MgCl2. Is this clear? Yes or no? Clear? This one.
Yes.
Yes.
Achha, so let's try and do another one. Aluminium with, let's say, sulfuric acid, which is H2SO4. So again, you want salt plus H2 gas. The salt would be get rid of the H, put aluminium in its place. It's going to be Al and SO4. But do the crisscross again, make the formula. It's going to be Al plus 3, SO4 is minus 2. So it's going to be Al2 and SO4 would be thrice. Okay, that's your reaction. So it's going to be aluminium sulfate. And you can balance both of them. The first one, only the Cl is not balanced, this one. So you can have 2 HCls. In the second one, the Als are 2. So there would be 2 Als over here and there would be 3 SO4s. So multiply this by 3. That would make hydrogen 6. So this should be multiplied by 3 as well. So that equation is also balanced now. So metal plus acid produces salt plus H2. So kind of a similar reaction. Then the next one is, it's a reaction of carbonates with acid, number 3. So a carbonate is something that has CO3 minus 2 ion. So there must be some positive ion next to it. It might be a metal. Metals are the ones that form positive ions. Or it could be ammonium, another positive ion. So it could be ammonium carbonate. So carbonates with acids, they have a similar reaction and they produce salt and water and carbon dioxide. These are going to be produced. Now, so I'm going to pick, let's say, sodium carbonate, which is Na is group 1 plus 1, CO3 is minus 2. So the formula is going to be Na2CO3. And I'm going to react it with phosphoric acid. So it's going to produce water and carbon dioxide and a salt. So salt would be produced, get rid of the H, put Na in its place. It would be Na and PO4. Na is +1, PO4 is -3, so it's going to be Na3 PO4. And you can rub off the charges. You get the overall charge is 0, and you can start balancing it. So again, balance with the easiest first. I'm going to balance sodiums, the ones that come in the least number of places. So we can pick sodium, that's 3, that's 2. So I'll multiply this by 3 and I multiply that by 2. And that would balance out sodiums. Then which one is the easiest to balance? I can balance carbon. There's only 1 carbon here, but there are 3 molecules. So that's 3 carbons. So I'm going to multiply this by 3. So I can have 3 carbons. Which one is the easiest, least number of places? Phosphorus, that's only 1 inside the bracket. Outside, that's 2. So that's 2 phosphoruses. So I'm going to multiply this by 2 because there's only 1 P. Now you've got 2 P. That's again the easiest first. I mean, ignore oxygen. Oxygen is the most difficult one. It's in every place. So just ignore oxygen. Hydrogens, there are 6 of them. So hydrogen is only in 2 places. Balance it. I'll multiply that by 3. That would be 6 hydrogens as well. Now the last one is oxygen, and that would balance itself out automatically. 9 oxygens over here. You've got 8 oxygens over here, so that's a total of 17. 8 over here, 3 over here, so that's 11, and 6 over here, that's 17. So this equation is now balanced. Is this clear? Yes or no?
Yes.
Baz, Izan, is this clear? Sadina, is this clear?
Yes, sir.
Okay, so so now we have let's do more of these. Let's take calcium carbonate. Calcium is +2, group 2, carbonate is -2. Reacted with, let's say, HCl, hydrochloric acid. So it's going to produce salt, get rid of the H, put calcium in its place. It would be calcium and Cl. Calcium is +2, Cl is -1, so it's going to be CaCl2. Plus there's going to be water, and there's going to be carbon dioxide. So you'll have all of these. So you're going to have all of these. Now, next is so next, and you can balance this out. You can rub off the charges. The only thing that's unbalanced is the Cls. So you balance it out, and the rest is balanced. Carbon 1, there's 1 carbon. Calcium is 1, 1. H is 2, there are 2 H's. Oxygen would automatically balances 3 oxygens, and over here there's 2 + 1, that's 3 oxygens. So that is also balanced. Let's try and do aluminium carbonate with nitric acid. So aluminium group 3, that's +3, carbonate is -2, so it's going to be Al2, and CO3 would be thrice. Plus reacted with nitric acid. The salt would be produced, get rid of the H and put aluminium in its place. So it's going to be Al and NO3. Al is +3, NO3 is -1, so it's going to be Al, NO3 thrice, plus water, plus carbon dioxide. And let's start balancing it. We have the formulas, all the formulas are fine. Start off with the easiest, aluminium. So there should be 2 aluminiums here. So multiply this entire thing by 2. Which one is the next easiest? Balance carbon. There's inside the bracket, there's only 1 carbon, and outside the bracket is 3. So that's 3 carbons. So over here, I'm going to multiply this entire thing by 3. Then what else? The easiest first. Nitrogen. Inside the bracket, there's only 1 nitrogen. Outside the brackets, that's 3. So you got 3 nitrogens, and there are 2 molecules. So that's 6 nitrogens over here. So there are 6 nitrogens over here because it's getting multiplied by 3, and then it's again getting multiplied by 2. So I'm going to multiply this by 6. There's only 1 nitrogen here at the moment. and I'm going to multiply that by 6. And so that balances nitrogen. Again, the easiest to balance next one is H. 6 hydrogens, multiply this by 3. So that's also balanced. And oxygen would balance itself automatically. So you've got 9 oxygens and there are 18 oxygens over here. So that's 27 oxygens. You've got 9 oxygens and there are 2 molecules. So that's 18 oxygens plus 3 oxygens. That's 21 plus there are 6 oxygens. That's 27. So the most difficult one would automatically balance itself out. And we can try one more. Let's go with let's go with magnesium carbonate. Mg is 2 plus, CO3 is minus 2. With phosphoric acid, that's H3PO4. So again, get rid of the H, put Mg in its place, that's your salt. Mg is group 2 and PO4 is 3 minus, so it's going to be Mg3, PO4 twice plus water plus carbon dioxide. And balancing it, 3 mgs, so multiply this by 3. How many p's? We've got 1 p inside the bracket, and outside the bracket it's being multiplied by 2, so over here it's going to be 2 p's. Carbons, there's only 1, but outside the bracket it's 3, so the 3 carbons. So over here it's going to be, I'm going to multiply it by 3. Hydrogens, 6 hydrogens. Over here there are just 2, so you multiply this by 3, and forget about oxygen. Oxygen would automatically balance itself out. So the thing is, a carbonate reacts with an acid to produce salt, water, and carbon dioxide. So hopefully, is this Siddha, is this clear? Oswa, is this clear?
Yes.
Yes, sir.
So remember, you have to practice this. These are some things that are very basic, very fundamental to chemistry, reactions of acids and bases. So I wrote down a lot of reactions. I'll go through right at the beginning. We wrote down many reactions. So far we have done this metal plus acid reaction. We've done the metal oxide hydroxide reaction. We've done the metal carbonate reaction. Let's do number 4 and number 5. Ammonia plus acid, which is an easy one. So let's do so let's do this was number 4, I think, which is ammonia, which is a base plus acid, and it produces ammonium salt. That is the reaction. Now, in this reaction, you have ammonia, which is going to be acting as the base. So it would accept H plus 1 ions. You react it with an acid, it's let's say HCl. So what's going to happen is the HCl is going to donate the H to ammonia. And it would form ammonium ion. It would form NH4 plus 1. And whatever left of the acid would be Cl minus 1. So it's going to form, the end result would be ammonium chloride. The HCl is acting as the acid. It gives away or produces H plus 1 ions. So it produces H plus 1 ions and gives those H plus 1 ions to the base, which is ammonia in this case. So that's your reaction. You always get an ammonium salt. And most of the time the reactions are kind of very simple, but you should have an idea that this is a purely typical acid-base reaction. So next one, you've got ammonia plus, let's say, sulfuric acid. Same thing would happen. Ammonium salt, get rid of the H, just put ammonium in its place. I mean, SO4 is -2. So if you do crisscross, it's going to be ammonium sulfate is going to be this thing. So just put, assume that the H are gained by this thing, and this H would get replaced by ammonium. Ammonia with phosphoric acid, same thing. Get rid of the H and you'll have PO4, which is -3. So it's going to be NH4 3 and PO4, right? Is this clear? ठीक है everyone, is this clear? Ahmed, is this clear? Mars?
Yes, sir.
Yes.
So that's an ammonia plus acid reaction. In any acid, like ammonia plus nitric acid, same thing. So just remove the H, ammonium is going to take its place. Ammonium nitrate. Okay, the NH3 is going to gain the H+1 ions, and what's left is nitrate, so ammonium nitrate. So these are your reactions. That's reaction number 4. The reaction, I said, now what are these ammonium salts? I'll also some more O-level stuff. Ammonium salts are frequently used as NPK fertilizers. In O-levels, most fertilizers, plants need nitrogen, phosphorus, and potassium. For plant growth, 3 elements are very, very essential, which is nitrogen, phosphorus, and potassium. So mainly for plant growth, these 3 elements. So most of these fertilizers, for example, ammonium phosphate has N and P both in the formula. So plants would need that. Plants would need nitrogen and they would need phosphorus as well. So if you look at ammonium nitrate, it's got 2 nitrogens. So plants need N, P, and K. So ammonium salts are frequently used as fertilizers because they contain nitrogen, a lot of nitrogen. Now the next reaction, the 5th one that we're going to do is this one. It's the reaction of, what was the reaction number 5? It was an ammonium salt would react with a base, most likely a metal oxide or a hydroxide. The ammonium salt acts as an acid. And the result is salt, water, and ammonia are going to be produced. So the pungent smelling, sharp smelling ammonia gas is given off in this reaction. So take any ammonium salt. Ammonium salt it's pretty much any compound that has ammonium in it. For example, you've got NH4 +1 and Cl -1. And you've got a base, let's say I've got a hydroxide like sodium hydroxide, Na +1, OH -1. Now what's going to happen is that this reaction is an acid-base reaction. Why? Because the NH4 +1 produces H+1 ions. So this NH4 +1 over here in the ammonium salt gives off NH+1 and it turns into NH3 gas. So that's how you get ammonia gas. So this one is losing, specifically this one is, one second. So this one over here, I don't know why there's a 3 on top. I say it just turns into NH3. So this one over here, NH4 +1 turns into NH3. That's why you get ammonia gas. It loses NH+1 ions. So that's the first thing. And now who gains that H plus 1? The OH minus 1 is the one that ends up gaining, it gains that H plus 1 ions. And it turns into water. So OH minus 1 accepts the H plus 1, turns into water. So it's acting as a base. And what's left? Na and Cl are left. That is, so whatever is left is basically your salt. It's NaCl. Okay, that's your reaction. So I just gave you a brief overview of why this reaction is an acid-base reaction. And the reason for that is that the OH ions are turning into water. They're gaining H plus 1 ions. The NH4 plus 1 are turning into, I mean, they're acting as bases because they're the ones that lose H plus 1 to form NH3. So it's an acid-base reaction. Like NaCl is not doing anything. It's just a spectator ion. It's not doing anything. The reaction is between the OH ions from the base and the NH4 plus 1 ions from the ammonium salt. So is this reaction clear? The background of this reaction, is this clear?
Yes.
So now, when you write the reaction, that's pretty easy. Like if you take any ammonium salt, like anything that has ammonium in it, it would be ammonium with some negative ion next to it. So let's say I'm talking about ammonium phosphate. PO4 is -3. So it's going to be NH4 thrice and PO4. So if I react it with, let's say, any base, barium hydroxide, all you have to do is think of NH4 turning into NH3 and think of the OH ions turning into H2O. So what are you left with? The salt is whatever is left, barium and phosphate. So barium is 2 plus and phosphate is 2 minus, 3 minus, sorry. So it's going to be barium 3 and phosphate would be twice. And that's going to be a reaction. That's the salt that's going to be, that's the salt that's going to be produced. And you can balance this. So the way to balance this is, again, the same method, balance the easiest first. Like you've got 3 bariums over here. So I'm going to multiply this by 3. You can remember once the formulas are made, you can't really change the formula. So what about P's, PO4 is there twice, 2 of them over here. PO4 is bracket twice. So I'm going to multiply this by 2 as well. So how many ends do I have? Inside the bracket, there's only 1. Outside, that's 3. And then it's being multiplied by 2 as well. So that's 6 nitrogen. So I'm going to multiply this by 6. Then you've got O and H. So I'm going to try and balance O. 8 of them. And there are 6 of them. 2 over here. And 3 outside. So that's 6. So that's a total of 14 oxygens. So I've got 8 over here. There should be 6 oxygens over here. So I'm going to multiply this by 6. So that's the reaction. Ammonium salts reacting with metal oxides. They produce salt, water, and NH3. Let's pick any other ammonium salt, NH4 plus 1 and SO4 minus 2. So it's going to be NH4 twice, SO4. Let's react it with KOH, which is a base. The NH4 will turn into NH3, so that's ammonia. The OH ions will turn into water, so that's the OH ions are gone. The NH3, NH4 and OH ions are gone. What's left is K and SO4. So K is plus 1. SO4 is minus 2, so it's going to be K2SO4. And that's going to be your entire reaction. So that's a reaction. And we just need to balance it. So there are 2 Ks over here. So I'm going to multiply this by 2. And they're twice, NH4 is twice. So I'm going to multiply this by 2 as well. 2 NH3s are going to be produced. And we've got one sulfur, that's fine. Oxygens 4 plus 2, 6. So there are 4 oxygens. There should be 2 over here. So that would be multiplied by 2 as well. So this equation is now also balanced. Is this clear?
Yes.
So just a quick recap of the first 5 reactions that we've done. TK, most of them were acid-based reactions. So remember, ammonium salts, they react with bases and they produce salt, water, and NH3. In this case, it's pretty easy to spot what's going on. The NH4 is turning into NH3. The OH ions are turning into water. And what's left is NaNCl. That's your salt. Number 4 was quite easy. That number 4 was, you've got an ammonia plus acid reaction, and it would produce simply ammonium salt. So get rid of the H and put ammonium in its place. And do crisscross, that's it. So you'll get your salt. You had a carbonate plus acid reaction. The only difference was now it's carbonate plus acid produces salt, water, and carbon dioxide. So again, get rid of the H, put Na in its place. So that would be the salt, which in this case would be Na and PO4. Over here, it's going to be Ca, put CnCl. And over here, also think like this, that carbonate turns into carbon dioxide. The H gains the oxygen to form water. The acid would always lose its H. So whatever is left is the salt. NaPO4, Ca, and Cl, Al, and NO3, Mg, and PO4. Because the acid would release the H+1 and would react with the carbonate. So water and carbon dioxide would be produced. So whatever left is the salt. Then we did a metal plus acid reaction. And I'll just do one more metal plus acid reaction. There's just too few. You've got calcium plus phosphoric acid. Get rid of the H, put calcium in its place. It's going to be CnPO4 plus H2. And the thing is, Ca is +2 and PO4 is -3. So it's going to be Ca3 and PO4 twice. So that is, and you just need to balance it, 3 calcium. So there should be 3 calciums. You've got PO4 is twice. So this should be multiplied by 2. And then if you've got 3 H2 gas molecules, right? So is this clear? The first 5 reactions. If you don't have the board link, I'll share the board link again. So this will be your homework. Try and make these equations. Remember, we did 5 equations so far. So the first one is with metal oxide. So let's take calcium oxide with sulfuric acid. The same thing, calcium oxide with phosphoric acid. So that's reaction number 1, reaction number 2. Then let's talk about the carbonate plus acid reaction. So let's take iron 3 carbonate. Remember, transition metal, the charges are given. So react it with the hydrochloric acid. So salt, water, and carbon dioxide would be produced. And the same iron 3 carbonate with sulfuric acid as well. And they should be balanced equations. And so then you've got, so that's number 4. Number 5 is, let's do an ammonium salt reaction. Let's say I've got ammonium nitrate and reacted with calcium oxide. And you've got ammonium chloride reacted with iron 3 hydroxide. So 6 reactions that you need to do. I'm posting it in the group as well and sending an assignment for that. Tiki, you can start now. Make sure you practice them. Let me just quickly post this in the group. Just 1 second so I can share the link for the assignment. So this one is, so make sure you complete the previous work as well for formulas. 5 have been turned in, so that's fine. Just a second. Just 1 second, let me share the. Okay, I'm sharing the link. Do the assignment. For balanced equations. Okay, that's make balanced equations. That's an assignment. I've posted a link in the classroom as well. There's 6 of them. So try and go through. I've shared the link to the board as well. So try and complete this. Okay. So let's continue tomorrow. Is this all clear? Ahmed, is this clear? Maz, Izhan, Oswai, everything clear?
Yes.
Yes.
So we'll hopefully try and go through all the equations tomorrow and hopefully start moles tomorrow. Okay.
Sir,
Yes.
so where do I have to submit these assignments?
Nee, I'm sending the link as well. I'll Google Classroom. This is the code. Do you use Google Classroom?
Yes, I have used it, but whenever I use this link
Acha.
to this classroom, it always says that there is no such class.
Actually, I've
There's
sent.
only one method.
Sir, ठीक है, I've sent you the classroom code. ठीक है, उधर जाके ना classroom.google.com. There's an option for joining class. To use this code over there. सही है?
Okay, sir.
चलें ठीक है. Okay, take care. Allah Hafiz.